Hello and welcome to another video. This is Cracking the Cryptic app Fog of War pack puzzle number 33. Now is the winter of our disjoint sets. The rules are Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column and box must have all numbers from 1 to 9 exactly once. Killer. The cells in each cage must sum up to the number in the top left corner of the cage and numbers cannot be repeated inside the cage. Partial Kropki. A white dot between two cells indicates that the neighboring digits are consecutive. A black dot between two cells indicates that one of the digits is twice as big as the other digit. Not all possible dots are given. Disjoint sets. Digits must not repeat at corresponding box positions. What does it mean by corresponding box positions? Well, if this is, for example, a number 2, then number 2 cannot show up here, 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 or here. So, and for example, if it's in the top left of this box, then you cannot have the same number in the top left corner of any other box. Now, this is the rule that made us make a mistake in the last video. This video is actually a re-upload of the previous puzzle. Why? Because as I was selecting, for example, if a number 6 was here, as I was selecting all the other boxes, in one point of the video, I misclicked. And it caused the entire video to have that one mistake. And it's not a huge mistake in the sense that we derived the right conclusion from the mistake, but it is an invalid step, so now I have to remake the video. So, without further ado, let's begin. We are given a few black Kropki pairs, and we know that these cells cannot contain numbers 5, 7, and 9 because no value doubles into these numbers, and a double of their value is over 9. So you can only have 1, 2, 3, 4, 6, and an 8 here. Oh my god. Wrong notes. 1, 2, 3, 4, 6, and an 8. Okay. Now, we also see some more things. We see that this is a cage that sums up to 4, and it goes to the right. And we know that this cage cannot be 3 cells long because digits cannot be repeated inside the cage. And that means that if it was 3 cells long, the lowest values these 3 cells could have is 1, 2, and 3, and that would already be summing up to 6. So a cage that's 3 cells long must sum up to at least 6, and this sums up to 4, so it is therefore just 2 cells long. And the only configuration that works is 1 and 3. So we know that this does not contain any other value except for 1 and 3. Same up here. This cannot be 3 cells long because if it was, then the lowest values would be 1, 2, and 3, which already sums up to 6. So this must be either 1 and 4 or a 2 and 3. And now that is everything. So let's just quickly select every other cell in the grid and fill it with every possible value that these cells could take. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, immediately we see a 1-3 pair right here, so we know that none of these values can have a 1 or a 3. And because this is a black Kropki pair, and it doesn't contain a 3, then this cannot have a 6 in it. And furthermore, now this is 2, 4, 8, 2, 4, 8. You'll notice the number 4 has to be somewhere here for the black Kropki to work. For example, if a number 2 is here, then the 4 is here. If a 4 is here, then 4 is within these 2 cells. And if an 8 is here, then again, the 4 is within these 2 cells. So number 4 must be somewhere in there, and it cannot show up anywhere else in the same row. And since this is just 1 3, then this cannot possibly contain a number 8, because it's a black Kropki pair. All right. Now, let's take a look at these cells. These 6 cells. You'll notice that these 6 cells only have 6 possible candidates that could go in them. And they are numbers 1, 2, 3, 4, 6, and 8. And the disjoint sets rule says that digits must not repeat at corresponding box positions. So since these cells are the cells containing 1, 2, 3, 4, 6, and 8, then the cells in corresponding positions cannot contain these numbers because these 6 candidates go in these 6 cells. So here, here, and here, you cannot have 1, 2, 3, 4, 6, or an 8. leaving us with 579, 579, 579. This will be very important. Now, let's take a look at this pair, this black Kropki pair down here. Can this have the number 1 somewhere? Well, if it did, the other number would have to be the number 2, right? But a 1-2 pair down here means that you don't have a 1 or a 2 as a part of this square right here, this cage right here. And now this would be a 3 and 4, which sums up to 7 and not to 5. So that does not work. So number 1 cannot show up down here. What about a 2? Well, a 2 now only has the number 4 to pair with it, but without the 2 and the 4 in this column, this is 1 free, 1 free. And remember, we already reasoned and shown that this cage is exactly 2 cells long, so now that means that this sums up to 4 and not to 5, which obviously does not work. So this cannot contain the number 2 either. What about the number 4? Well, if it had a 4, now the 4 needs an 8. But without the 4 and the 8, this is the number 2. So now this does not have number 2, and because 4 is now here, it also doesn't have a 4. So again, it's 1 free, which sums up to 4 and not to 5. Therefore, number 4 cannot show up down there, and now number 8 has nothing to pair with it, so it's also not there. This gives us a free 6 pair. So you cannot have 3 or 6 anywhere in the same box or column. And without the number 3 in here, 2 cannot be paired with anything to make the 5. So this is a 1-4 pair. And you therefore don't have a 1 or a 4 anywhere in that box or column. All right. Remember how we said number 4 has to show up in one of these 2 cells? Well, since it's not here, then it must show up here. All right. Now, we should take extra care that whenever we place something, we clean it from every corresponding spot. All right. Let's take a look down here. You'll know that since this is a black Kropki pair, it cannot contain numbers 5, 7, and 9. And this also cannot be the number 1 because number 1 doesn't have 2 consecutive values on its sides. Can it be the number 2? Well, a number 2 needs to have numbers 1 and 3 on its sides in some configuration. But if 1 and 3 were on its sides, then this cell would be empty because its only candidates are 1 and 3. So number 2 cannot be down here. And it also cannot be a 3 because number 3 needs to have 4 and 2 on its sides. But number 4 is already taken in this box. So therefore, this is not the number 3. Therefore, you cannot have a 1, a 2, or a 3 anywhere there. Furthermore, this also cannot be a 6 because if this was a 6, it would force this to be the 8. And they're not consecutive. So this cannot be a 6. And it also cannot be an 8 for the same reason. And same here. 6 and 8 cannot be there. And now 579, 579, 579, that's a triple. Meaning that you cannot have 5, 7, or a 9 anywhere else in that column. All right. We ask the question, can a number 1 show up anywhere here? Well, if it did, then number 2 has to show up there as well to make the white Kropki pair work. But in that case, you would not be having numbers 1 and 2 anywhere else, meaning that this is a free 6, but without the 3 and the 6, number 8 would be showing up twice in this box, which is obviously a contradiction. So a number 1 cannot show up there. How about a number 2? Well, a number 2 needs a number 3 now, but without the 2 and the 3, you'll notice that this is not a valid black Kropki pair. This is just a 6 and 1. So therefore, number 2 cannot show up there as well. So now you'll see that numbers are a bit scrunched. Is that the English word for it? Because numbers 1 and 2 have to show up in one of these 3 cells. So let's ask the question of, does the number 1 show up here? If that is the number 1, well, then you would not have a number 1 here. And since this is a 3, then this would be a 6. And now a number 2 doesn't show up anywhere in this box. So therefore, number 1 cannot be up here. So the only place left for the number 1 in this box is right here. So this is a 1, this is a 3, and this is the 2 because of the black Kropki pair. Now, before we forget, let's just select every corresponding position carefully. See, that's how I made the mistake last time. I just misclick. And let's remove number 3 from all of these cells. Now let's do the same for the number 1. All right. And the same for the number 2 in the center. Number 4 was already taken care of. And now we do the number 8. All right. All right, so this thing revealed itself. Now this is the number 4. And this is the number 1. So let's first clean the number 4 everywhere. And now let's do the same for the number 1. Okay. Now, this thing cannot be a number 8 because there's no 4 to pair with it. And this thing cannot contain 5, 7, or 9 because it is a black Kropki pair. Furthermore, can it contain a number 2? Well, no, because number 1 and 4 that could pair with it are already taken, so this cannot be a 2. And it also cannot be an 8 because 4 is taken. So therefore this is the 6 and this is therefore the 3. So let's just quickly clear 6 from all candidates. All right, and now let's do the same for the number 3. All right, now this is the number 1 and this is the number 2. So again, let's just select everything. I have to select even the cells that I already see are filled in just to keep the symmetry so I don't make a mistake again. And this is number 2. Okay. Now, this reveals something new. It reveals a cage that sums up to 14, which is at least 2 cells long. All right, and we also see that these digits down here are consecutive. Now, does that tell us anything? Well, if this was the number 5, then this would have to be at least 7, right? And they would not be consecutive, so this cannot be the number 5. 4 works with the 5, 6 works, 7 works. Yeah, everything else works. Okay, now this cannot have the number 3 in it because nothing would be consecutive with the 3. So therefore, this is the number 3. Now let's clean the number 3. All right. So that leaves only one space for the number 3 in box number 4, and it is this space. So again, let's just make sure that no cell in the bottom left corner of a box has the number 3 in it. Okay. Now, since this thing can only be a 3 or a 6, and this is a black Kropki pair, that means that this cannot be a 1 or a 4 or an 8. So this must be the 6, and then this must be the 3. So let's clean the 6 from the top right corner everywhere. And number 3 already doesn't show up in any rightmost corners, so that should be fine. But this is the number 3. This is a 6. So number 3 doesn't show up in the bottom right corner. That is already taken care of. right? Yeah. And number 6 cannot show up in middle right corner anywhere, which is again already taken care of. Okay. Now, let's see what else we can do. This cannot be the number 1 because this is a black Kropki pair. It also cannot be an 8, so this is either a 3 or a 4. Let's go through the digits a bit more slowly. So another thing was revealed actually. This is a cage that sums up to at least 15. That sums up to 15 and it's at least 2 cells long. And these 2 digits are consecutive down here. So we should get back to that a bit later. A number 1, you'll see, has to show up somewhere here, meaning that number 1 is nowhere here. And therefore the only place left for the number 1 is right here. So number 1 cannot show up in the top right corner anywhere, which is already taken care of. And number 1 is therefore here. And that means number 1 cannot show up in the bottom middle corner right here. And now that means number 1 is somewhere here, meaning that it cannot be up there, so it has to be here in this box. All right. Let's keep going. Number 2. Okay. All right, it's a bit too complicated. I don't think we can solve it yet. Number 3. Number 4. So number 4 is here or here, meaning that it cannot be anywhere up here. And furthermore, you'll see that we have something new. We see that this is the actual length of this cage, because this is no longer in fog of war. So this sums up to 14, and therefore it cannot have a low value like 2, because if a 2 is here, a 9 is here, that's 11, that's not 14. So it cannot have a 2. Can it have number 5? Yes, 5 plus 9, that works. What about a 7? A 7 can't be here because 7 needs another 7 to make the 14. And you cannot have 7 showing up twice in the same cage. How about an 8? An 8 needs a 6, but a 6 is already taken. So 8 cannot show up here. And 4 is too low. 4 plus 9 is 13. So therefore, this is the 5-9 pair. Therefore, you don't have a 5 or a 9 anywhere else in that column, giving us the number 7 right here. So let's just clean number 7 from all the corresponding positions. All right. Okay, that's the number 7 placed. Let's go back to number 2. Nothing really new over here. Yep, let's check the 3. Still nothing new. Number 4. So a number 4 has to be here in this box. And that means that number 4 cannot be anywhere else in that corresponding position. And that finally gives us something new. This has to be the number 3. And because that's a 3, then this is a 6. So let's just quickly clear number 3 from the corresponding position, which is here. And now that solves all the 3s. And we should clear number 6 from all the corresponding positions as well. If it isn't already done for us, actually, it is already done. So we have number 6 showing up here in this box. And that means, since 6 is here or here, that 6 cannot go over there. All right. Now, since these 3 values are consecutive, this cannot be the number 9, meaning that 9 is up here, and therefore 8 is also here. So that's an 8-9 pair, meaning you don't have an 8 or a 9 anywhere else. And that means that this is the number 5. So let's just clean it. And this is the number 2. And this is the number 9. Okay. Now you'll see that we have something interesting. We have a 5-7, 5-7 pair in the top right corner of this cage, of this box and this box. And since 5-7 has to show up in these positions, that means the 5-7 cannot show up anywhere else in a corresponding position, because if this was a 5, then both of these would be a 7. So this cannot be a 5 or a 7. And for the same reason, since this is a 4-8, 4-8 in the top right corner of a box, then this cannot be a 4 or an 8, meaning that this is the 9. And now a 9 cannot show up anywhere in the top right corner. And a 9 must show up here, meaning that it's never in the bottom left corner. All right? And therefore this is the 5. So 5 is never in here. And this is the 9. So a 9 is never in the center. Okay. What else? What can we do? So 1, 2. Number 2 is either here or here, meaning that it cannot be over here. Okay. Number 3s are solved. Number 4. Okay, number 5. Nothing really new. 6. 7. 8. 9. Okay, let's take a look at these two consecutive values. Obviously, this cannot be the number 8, because if this was an 8, this would be a 5. So this cannot be the 8. 4 and 6 work with the 5, and 7 works with the 8. Let's ask the question, can this number be the number 4? Well, if that's a 4, then this has to be the number 5, right? But in that case, this value right here would be the 8. And you would not have an 8 anywhere here. So this would be 2, 5, 7, meaning that this is the 8. Which works pretty well because an 8 is over here. However, this runs into a problem because 5, 7, and 9 has to be in these 3 cells. But number 5 is over here. And without the number 5, this is 9, 7, and then this cell has to be empty. Therefore, number 4 cannot show up over here. Now, 5 can still go here to work with the 6 though. But we know number 4 cannot go there. And because of that, number 4 is either here or here, meaning that it's nowhere down here. And therefore, number 4 is up there. With the 4 placed in the top right corner, we can now place number 8 right here. And there's no corresponding cells to fix. All right, let's assume now that a number 1 shows up somewhere down here. Well, if a number 1 showed up down here, number 2 would also have to show up down there because they're consecutive. And then you would not have numbers 1 and 2 anywhere here. So this is a 6, meaning that you don't have number 6 anywhere else either. And look at this. This thing has to sum up to 15, right? And how can it sum up to 15? For example, if this was a 9, then it simply cannot sum up to 15, right? Because 9 plus 5, that's 14, and then this is not number 1. 9 plus 7, that's already 16, so this cannot be a 9. Can it be a 7? Well, if that was a 7, then this is a 5, that's a 12, plus 6, that's too high, right? So this also cannot be the 7. Can it be a 5? No, because you run into the same issue. 5 forces this to be a 7, and the configuration doesn't work. However, the only configuration that does work is this one. 4, 6, and 5 over here. So this is now a 15. But 5, 4, 6 means that number 9 doesn't show up anywhere in this row. And that's a contradiction. So that means numbers 1 and 2 cannot show up in those 2 consecutive digits. Or rather, number 1 doesn't show there, right? And without the number 1, number 2 doesn't show up anywhere because it has nothing consecutive with it. And now, let's take a look at this thing right here. Can this number possibly be a number 1? Well, this cage sums up to 15, right? And it's either 2, 3, or 4 cells long. So if it has number 1, obviously cannot be just 2 cells long because maximal value here is a 9, which will give you a 10. So it has to be either 3 or 4 cells long if it contains the number 1. Let's assume first that it's 3 cells long. And sums up to 15. So since our assumption is that it has number 1 right here, we're going to only consider cases that do contain a number 1. Can it be a 159 in these 3 cells? No, because this is either a 2 or a 6. So it cannot be 159. How about a 168? No, again, because an 8 is taken in this box, so this cannot have an 8. So it does not work if it's just 3 cells long. How about 4 cells long? We know that it can be longer than 4 cells, right? Because we simply see that it doesn't go anywhere else. So now let's gray out the case that doesn't have the number 1. And we see number 3 is already taken, right? So it cannot contain the number 3, meaning that this case, this, and this case, they don't work. Okay, so what if it's 1, 2, 4, 8? Let's assume so. Let's assume that this is 1, 2, 4, 8. Well, in that case, you would not have 2, 4, or an 8 anywhere. But without the 2, 4, and 8, this cell would be empty. And that's a contradiction because it must contain one of the values. It must contain either a 4 or an 8, right? So it cannot simply work if you remove the 2, 4, and 8 from its candidates. So that does not work. How about a 1, 2, 5, 7? Let's assume that this thing is a 2, 5, 7. In that case, we don't have a 2, a 5, or a 7 anywhere. But now 4, 8 is a pair, again, meaning that this cell has to be empty. And that's a contradiction. So number 1 leads you to a contradiction in all cases. It cannot show up as a part of this cage in this position right here. So therefore, this is not the number 1. And now, because number 1 is either here or here, no matter the position, number 1 cannot show up anywhere there, and it is therefore right here. Placing the number 1, let us know the actual length of this, and now we see that it is exactly 3 cells long. And because of that, we now know that this thing cannot have the number 9 here, because a number 9 here would be too high, right? Because if this is a 9 plus 2, that's 11. 11 plus 5 is already 16. So it's just simply too high. And if this is the number 2, then this is a number 6, it's still too high. So number 9 cannot go here. All right, so we've placed number 1. And let's think about what else we can do. This thing cannot be an 8, right? Because these two have to be consecutive. So this cannot be the 8. 5 works with the 4, 7 and 9 work with the 8. Let's go through the digits a bit more slowly. So 1, 2, 3, and 4. Okay. And then 5, 6, 7, 8, and then 9. So a number 9 now has to show up either here or here, right? Meaning that no matter the position, it cannot go in here. That leaves only one place for the number 9, and that is right here. Since this is the number 9, now this has to be the number 8. And now, since we placed number 9 in this position, it cannot show up in the middle bottom position anywhere, which is already solved. What about the 8? Now we have to clean the 8 from every corresponding position though. All right. So let's check again. We have to be very careful. So we've placed the 9. We've placed the 8. How about the 4? So number 4 has to go over here. That's the only place left for the 4. And now this is a 5, 5, 7, 5, 7 pair. Meaning you don't have 5, 7 anywhere else. Meaning that this has to be the number 2. And this is the number 1. So a number 2 cannot show up in the top middle place anywhere. And number 1 is solved in here, actually. Number 2 goes in the top leftmost corner. Okay. What else? Number 3 solved. Number 4 still too difficult. Number 5. Number 6. Seven. So a number 7, 5, 7 has to be somewhere here. It's somewhere here, right? So number 7 cannot be there. Number 8. And lastly 9. So a number 9 is either here or here, or here or here, meaning that it cannot be here. So this is an 8, and therefore this is the 9. So a number 8 cannot show up in the top left corner. It never did show up though, so that's not anything too new. Now, this is a quadruple of 5, 7, 8, 9, meaning that you cannot have a 5 or a 7 here, meaning that this is a 2, 6, 2, 6. Okay. Let's go again. So 1, 2, 3, 4, 5, 6, 7, 8, 'We see it something else. 6, 7, 6, 7 is a pair, meaning that you cannot have a 6 or a 7 anywhere else in this column, which gives us number 9 right here. Okay. What else? I can always just look at this gauge and reason about its possible values. And I think that even though it's a bit more annoying to think about it, it might be better to save up on time. So number 1 doesn't show up there. Same with number 3 and 8. So 8 cannot show up there. 3 cannot show up there. And number 9 also doesn't show up there. So it's either a 2, 6, 7 or a 4, 5, 6. So it must contain either a 7 or so how does the 2, 6, 7 work? 2 has to go on one side, 6 has to go on one side, and then this has to be the 7, right? So this can be a 7 in that case. This has to be a 7 in that case, because this cannot be either a 2 or a 6. What about the other side? Well, 4, 5, 6. This can be a 5. This can be a 6. And this is the only thing that can be a 4. So that basically means that no matter the scenario, this cannot be a 5. Because 4 and 7 cannot go. Actually, this can be a 7. Right? So let me check again. 2, yeah, but if this is a 7, then this cannot be a 2 or a 6. So that does not work. Yeah, so basically this, let's just reason a bit more slowly. Can this be a 7? If this is a 7, then we are in the 2, 6, 7 case, and then this cannot be a 2 or a 6, so this cannot be a 7. Can this be a 6? Yes, because this can be a 7 and this is a 2. Can it be a 5? If that's a 5, then we're in the 4, 5, 6 case. So if that's a 5, this is 4, this is 6, that works. And can this be a 6? If that's a 6, then we're in either case. And this can be 6, 2, 7, that works. Okay, what about here? If this is a 5, then we're in the 4, 5, 6 case, but number 4 doesn't show up anywhere else, meaning that this cannot be the 5. And 2, 6 here works. Okay. Now, let's see if maybe we can resolve this without any further assumptions. Let's just see, because we did get some stuff done with that. We did clean it up a little bit. But we might have to assume a certain configuration and then prove that that configuration doesn't work. So a number 5 is somewhere either here or up here, right? And that means that it cannot go here. So this is a 7, and therefore this is the number 5. So with the number 7 placed, we know it doesn't show up anywhere in the bottom left corner. That's already clean. And number 5 doesn't show up anywhere in the bottom right corner, which is also already clean. So 7 and then a 5. So, okay, so let's see. If this is the number 4, then we are in the 4, 5, 6 case, right? So you have 6 has to go over here then, right? And then this has to be the number 5. So we don't have a 4, a 5, or 6 anywhere, meaning that this is the 7 and this is therefore the number 2. Now, without the 2 and the 7, that makes this the number 5, so this has to be the number 8. Therefore, this is the number 5 right here, and then since they're consecutive, this has to be the 6. So if this is the 5, 4, 6 case, then this has to be the number 6 up here. Let's check the other side. So we've assumed that the middle one is the 4, and we've reached the conclusion. So this was assumption that this is the 4, and then this was a 6 right here. Let's assume that this is a 7 instead. If that's a 7, then we are in the 2, 6, 7 case. But no matter that, if this is a 7, you'll notice that, so first we have 2, 6 on the sides, right? Oops. So 2, 6, and 7 aren't here, and because 4 is here, then this is a 5. And now, since a 7 and a 5 are in this position, you cannot have a 7 or a 5 in that position, giving us an 8 here. So an 8 is not up here, meaning that 5 and 7 are here. And therefore, a 7 and a 5 cannot be there, again giving you a 6 in the square. So by elimination of disjunction, since this square right here is either a 4 or a 7, we get that a number 6 has to be here since both cases imply that it is there. And because these two numbers are consecutive, then this has to be the 5. And so this is the 4, this is a 7, 6, 2, and things have started clearing up a little bit. So that's the number 8. Then this is the 9. So a 9 has to go down here, and now all the 9s are done. Number 1s are done, number 2 goes here, meaning that this is a 6, 5, and now because we have a 6 and a 5, this must be the number 4. This is a 7, 2, 7, 5, 4. This is a 5, 7, and the puzzle looks like it's going to be complete very soon. This is a 2, 5, 6, 8, this is a 7, and lastly 8, 7, 4, 8. All right, that was a fun puzzle. The first time I did it. This time around it was a bit more of a chore, but I hope you guys enjoyed it, and sorry about the mistake in the previous video. See you guys next time.